Hello everyone, this is Dr. Lennon, and we will be doing the two sections on statistics in this lecture. So we'll be looking at 6.2, measures of central tendency, which describes the middle of a collection of data, and 6.3, the measures of dispersion, which talk about how spread out data is. So these are kind of the basic central concepts to studying statistical distributions. And we'll also touch on the normal distribution, but it doesn't appear as if there's any homework on my math lab pertaining to those, but we'll look at a couple of examples. Okay, so let's jump right in. Something that probably we're all familiar with is the notion of the average, which is in statistics called the arithmetic mean. So the arithmetic mean we often refer to this as the average, is just the sum of a bunch of data values divided by the total number of observations. So most of you, I'm sure, are very familiar with this. Let's just suppose we take a student with a bunch of exam grades. So suppose a student has 4 test scores. Of 81, 86, 72, and 93. How do we compute the average? Well, the average is just you add all 4 up and then divide by 4 because there are 4 test scores that we're trying to find the average of. And this comes out to exactly 83. Okay, so that's one measure of central tendency, probably the one you're most familiar with, but there are others. The median is also one that is not too unfamiliar, I'm sure. So we can talk about that. The median is the middle data point when the observations are listed in increasing order. You could also do decreasing order, but I just prefer the increasing order. So that's one difference between the median and the mean. In order to compute the median, the first thing you have to do is you actually do have to write your data from smallest to largest with the mean. You can just add them up and divide. There's no need to arrange anything. But there are 2 possibilities here. And why are there 2 possibilities? Well, I'm talking about this middle data point. Well, what does middle mean? Well, on the one hand, you could have an even number of observations or an odd number of observations. So the odd number is the easier of the 2 cases. So an odd number of observations why is that easier? Well, there's exactly one middle number, which is going to be your median. Whereas if we have an even number of data values, then you have 2 middle numbers. So if you have 2 middle numbers, what do? Well, we just take the average of those two middle values, and that's what we're going to call our median. So let's look at a quick example. Again, it's not too difficult here. We can just say, all right, example, find the median for each data set. So let's suppose our first data set contains 5 values, and I'll have them written in increasing order already: 11, 28, 39, 76, and 101. Well, the middle number is just the 39 in the middle. You've got 2 to the left of it and 2 to the right of it, so our median in this case is just exactly 39. So if we look at another data set with an even number of data points, say 135, 176, 212, 239, and 317, and lastly 425. Well, here we have 6 data values, but there's not just one clear number in the middle. We kind of have our 2 middle numbers, the 212 and the 239. So to figure out the median here, what we have to do is just take the average of those 2 numbers. So in this case, the median is given by 212 plus 239 divided by 2, and this comes out to 225.5. So notice, if you have an odd number of cases, your median number actually appears in the list, whereas for B, our median is 225.5, which does not appear anywhere on our list, but it's still the measure of central tendency that we're describing using that formula. Okay, so a lot of times people are more familiar with the mean, and they, just assume maybe it's the better measure of central tendency. So I meant to write median, not median. Anyway, so the question to ask is, which is preferable? And this is maybe, if you could have one takeaway from this section, years down the road when you're thinking about, okay, how should I think about the center of the data? Maybe this is one to remember. So we'll kind of look at it through a motivational example. So let's just consider the annual income in thousands of dollars of 5 individuals. And these incomes are 28,000, 34,000, 42,000, 50,000, and $67,000 per year. So at this point, we can go ahead and say, okay, well, what's the average? The average is given by just the sum of those numbers: 28 plus 34 plus 42 plus 50 plus 67. And we take off of those and divide by 5 because that's the number of values we have, and we have $44.2 thousand per year as the average annual income of those individuals. Okay, then we could look at the median. The median, we are in the odd case, so we just look at the middle number up here, 42. So 42 is our median. And notice that those two things are pretty comparable. The median's pretty close to the mean there, or the average. But let's suppose we add an outlier to this conversation. So an outlier is just a number that's really, really far away from a bunch of your other values. And we can say, okay, well, how is that going to influence the data? What's going to be representing the center of this data better, the average or the median? So, what's a good outlier? Well, maybe we toss Jeff Bezos into the mix. So I looked at his 2018 income, which is actually probably a pretty low number because, well, a lot of these really wealthy people don't make most of their money from income, but from other means like capital gains, which, anyway, but we're talking about income. So I looked up his income from 2018. So let's add to this data set. Jeff Bezos's income. Well, I guess this is all of his earnings, not technically like his income, but we have, okay, so I'm going to write down here this number. So it looks like 40 million, but remember our annual income was per thousand. So this looks like 40 million, but really this represents 40 billion. So this is $40 billion in 2018. And let's compute the new average and median. So now what happens? Well, I'm not going to write down all the numbers, but if you do the average, in this case, you get, let's see, this large number, 6,666,703.5, and again, that's thousands. So really what this translates to, you'd have to add 3 zeros to it, and this is about $6.67 billion per year. So that's a huge number. The average has changed dramatically from $44.2 thousand per year to $6.67 billion per year. What does the median do? Well, the median, basically we can look back to the original list, and up here we're just going to have that big number from Jeff Bezos at the end, so then we get two middle numbers, 42 and 50. So our median is just 42 plus 50 divided by 2, which comes out to $47,000. So what happened? Well, we saw, which is a better measure of central tendency in this case? Well, the median is definitely representing the majority of the group's income a lot better. So 5 of those 6 individuals are earning an income way closer to the median than the average. So what is the takeaway? The takeaway is the median is more resistant to an outliers effect. So if you're thinking about a better measure, if these two things are very far apart, the average and the median, what's most likely happening is that you have some outlier, either a very small one or a very large one, that is influencing it. So for this reason, we say the median is more resistant to outliers than the average. All right. So from this perspective, the median and not the mean is the better measure of central tendency. Oops, a typo there. I want that to be a DE. Okay. All right, so what is next? Well, we can also talk about some other measures of the, let's say, the middle third and the last third. So when we talk about that, we're talking about quartiles. So we can talk about the first and third quartile. So what do the first and third quartile mean? Well, a lot of times we'll denote the first quartile by Q1. So this is the first quartile. And what this is the middle number between the minimum and the median. And then the third quartile what is this? This is the middle number between the median and the max. So one way to think about the first quartile, at least the perspective we're going to look at, is the first quartile is the median of the first half of your data points, and the third quartile is the median of the second half. So you can kind of think of it like this. We've got our min, we've got our max, and then you've got your median in the middle here. And then if you look at the median of the first half, that's the first quartile, and the median of the second half, that's the third quartile. Why are they called quartiles? Well, it chops up the line right there, your data values, into 4 sections. So some alternative names for the first quartile, median, and second quartile are in terms of percentiles. So Q1 is also known as the 25th percentile. The median you could think of as the 50th percentile. And Q3, we could think of that as the 75th percentile. So the collection of these numbers together are known as the 5-number summary. So the 5-number summary is just that. The min, Q1, the median, Q3, and the max, typically written from smallest to largest. You can draw an accompanying graph. The accompanying graph is known as the box and whisker plot. So this is called the box and whisker plot. And a lot of times you can do these on some program like Excel. But we'll do a couple by hand. I believe on the MyMathLab, it'll just offer you the graphs and you have to distinguish which graph is the correct one. So we'll see how that works. Okay, so now let's look at an example where we actually create a 5-number summary and sketch a box and whisker plot. So I've got this example below. So it says the weights of the current Bengals offensive linemen are as follows, and I've got a bunch of weights there. I don't think these are the actual weights. I just kind of made up a bunch of numbers, but they all seem reasonable. One thing that's a little bit of a pain is sorting these things. So you can go through by hand and do it, but the larger the data set becomes, the more unwieldy that task. So let me just show you how to do this in Excel, and we can kind of skip that step. So what you want to do is you want to highlight all your data values. So I'll just copy them. Control C is the keyboard shortcut, and then I'll go to an Excel page and I can paste those values there. So now it's listed, but the problem is it's only listed in one cell. So what you want to do is you want to split that out into a bunch of different cells. So under the data ribbon, there's this option that says text to columns for importing it. So if I click that, it gives me either a fixed width or a delimited. So delimited means they're all separated by some sort of characters, so such as commas or tabs or something like that. So all of ours are separated by commas, so we can click that option, click next, and then we can say, okay, well, they're separated by a comma, and then notice it separates them all for us. So we can just finish like that. So now all of our data points are separated, which is nice. So we've got them into Excel, so we can use all of these Excel tools. So let me just change the font on that. Anyway, so 1 second. I can't remember. I thought I could just right click and then it had the option. Yeah, format cells. There we go. Okay, so I just want to make it a bit bigger. Okay, so now we've got larger numbers, but they're still not sorted. So how do I sort? Well, there's this option here that says sort. So I can click sort, and then how do I want to sort? So this normally defaults to column. So if it's in column rather than, so notice if I click options and I click top to bottom, it's sorting by column, but all of our numbers are in a row. So we want to change that from left to right rather than top to bottom. We want to make sure that we select our data that's in row 1, and then notice it's ordering from smallest to largest. So I can click OK. Then I can copy that again, and I can go back to my notebook. I can say, okay, well, here is the ordered data now, and I can use that to figure out the 5 numbers that I care about. The first that are the most obvious are the 302 and the 345, right? This is our min, this is our max. We can look at how many actual numbers we have. I believe there's 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the median, we're in the odd case, so the median is just going to be the middle number. So if you've got 13 numbers, the middle number would have 6 above it and 6 below it. So that would just be our 7th number. So 1, 2, 3, 4, 5, 6, 7. So this number right here, 312, is our median. And then we want to decide what our Q1 and Q3 is. Now, I will tell you there's kind of 2 ways to do this, determining our first quartile and our third quartile. One method is saying, all right, I can consider the first half of the list 302 up to 312, and then I've got 7 numbers, so my Q1 would be 305. This is known as the inclusive method because you're including 312 in the first list and then also including 312 in the second list. The other method is the exclusive method. So you would exclude 312 and look at the first 6 numbers, and then you would have an even number of entries, which in this case would still be 305 because it appears as both middle numbers, and then in the second list it would be 318 to 330. So I'll kind of write both out, and then I'll show you actually how you could find that on Excel if you wanted. So our Q1 including 312, so Q1, I'll type INC inclusive. So there's 7 numbers in that list, and 305 would be the middle. You'd have 3 below and 3 above. So our Q1 inclusive would be 305, and our Q3 inclusive would be the middle number of the top list, which would be 318. So we include 312, so these 3 numbers are above 312, 315, 315, and those are the 3 numbers below, and the 3 numbers above are 330, 340, and 345. So Q3 inclusive would be 318. All right. If you want to exclude 312, then both of your lists would have an even number of data points, so you'd have to do some averaging. So when you look at the first half and exclude 312, you've got 6 numbers, 302 up to the second 310, and you've got 2 305s in the middle. So 305 plus 305 over 2 still comes out to 305. So Q1 exclusive is 305, and if you look at Q3 exclusive, your 2 middle numbers are going to be 318 and 330. So you're going to have to take the average of 318 and 330. So that's going to be 324. So we see that Q3 changed a little bit. And let me just show you. We'll walk back to Excel real quick, and I can show you that both of those commands are there. We'll just do Q3 since that one was different so you can see. So if I type equals and I do quartile, so notice there's two options, quartile exclusive and quartile inclusive. So we did the inclusive first, so let's go ahead and do that one. That's all we have to do is highlight our data and then tell it which quartile we want. So we want the third quartile. So Q3 inclusive is 318. And if we do the exclusive quartile, again, we need to highlight our data and then tell it we want the third quartile exclusive. We get 324. So that matches what we did back here in the notes by hand. But yeah, both of those commands are available to check your quartiles as well. So what does a box and whisker plot look like? Well, it's nothing really too fancy. You just kind of want to align your data. So we draw some graph here. And we have, some values. So if we go by fives, maybe we can go 300, 305, 310, 315, 320, 325, 330, 335, 340, and 345. So our max number is 345, so we would put a line there. Our smallest number is 302, so we guess that's right about there. And then what we do is, we could shade in the middle. So this is what's connecting those. And then what we want to do is put a box with a line somewhere in the middle of that box for the median. So Q1, let's use the inclusive values. Q1 would be 305, which would be right here. So this would be the beginning of our box. And then we go up to 318. So 305, 10, 15, 318 would be somewhere in here. And we get our box. And then the median is where we draw our lines. So 305, 310, 312 is right here. This is what our median is represented by. So that's what a box and whisker plot looks like. So you've got the box in the middle and kind of like these edges where you have your max and your min. Those are representing. So again, we've got our min, Q1 right here on this edge of the box, the median, Q3 on this edge, and then the max all the way over here. So that's a box and whisker plot. Pretty straightforward. Okay. So let's go on to the next topic. We'll talk about frequency distributions, which are basically kind of like running totals. They kind of group the data into some intervals and then count how many members of the data are in each interval. So let's go ahead and do that. So let's see. So let's define that frequency distribution. I'm still kind of getting the hang of writing with this pen tablet. I haven't used it in a little while, so my writing's not quite as neat as I'm used to. But anyway, so this is a way to group unorganized data particularly unorganized numerical data. So why don't we throw that in? Why don't we call it unorganized numerical data? So let me change that. So unorganized numerical data. There's other types of data you can look at that's non-numerical. Categorical, you could look at data that's looking at maybe like the color of cars, like red, blue, yellow, whatever. And those naturally fit into groups. But numerical data, you kind of have to make a decision on how you want to group the data. How large are your classes that you want to group it to, and so forth. So basically what you want to do here is you want to arrange scores into smaller groups called class intervals. And you also want to tally the number of scores in each class. Hello, so I've added this example where we want to create a frequency distribution with the following values here. So let's suppose we have a bunch of scores on an exam and we want to create a frequency distribution. Well, there need to be some particulars. So one thing is, if they don't tell you what the class width should be, you kind of have to make a decision on your own. But in this example, let's make the directions as follows. Let's create a frequency distribution with class intervals of width 5 starting at 60. Now, there's a couple different ways you could think about the class interval width. It depends on whether your data is continuous or discrete, meaning, are you allowing decimal points in any possible number between the values? In this case, notice all the numbers are whole numbers. So when we talk about a class width of 5, let's think about each bin as having 5 numbers. So basically what we want to do is we want to make a chart. So we have, let me do it over here. Let's say we have our class interval. So our interval will tally how many things there are in each interval, and then we'll do the total frequency of each class. So that will be enough. So let's first think about what our intervals are. So if they contain 5 numbers and we start at 60, our first interval would be 60 to 64. Notice that there are exactly 5 numbers if you count them in that interval. Then we would have 65 to 69, 70 to 74, 75 to 79, 80 to 84, 85 to 89, 90 to 94, and then 95 to 99. And notice this works pretty well for this example because we don't have any 100s on the exam. So no scores of 100. So what we do is we just go through and make an cross each number out and then figure out what the value should be. So, 76, we can cross that one off and put a tally mark in this interval here, 76. Then we have 91. 91 would go in this interval right here. 71 goes in this group. 83 falls into this group. 97 falls into the last group. 87 would fall right here. 77 would fall here. 88 falls in this group. 93 falls in this group. 77, and this takes a while, but it's pretty straightforward. And just go piece by piece, and hopefully you don't mess anything up. It's a little bit easier to just go one by one. If you want, again, you could copy and paste that stuff and sort it, and then maybe if you sort it, it's a little bit easier to keep track of everything. But I'm just going to work through one by one. So 77. Okay, 5 in that group now. 76. We're also still in that group. 97 in the last group. 87 in this group right here. 89 in this group right here. 68 in this group right here. 90 goes into this group down here. 84, 3 in that group. 88, 5 in this group, and 91. Second to last group, we have 5. So that leaves the frequency, the total count of 1, 1, 2, 6, 3, 5, 5, and 2. And that is our frequency distribution. It matches what I have in my notes, so that's a good sign. Let me see if I can erase these marks without erasing the text. Yeah, so I'll erase these so when I export the notes to PDF, you can see the numbers more clearly, but you just go through one by one and that's it. All right, so that is how you make a frequency distribution. They ask a number of questions too. So here's when we're interpreting these things, what other things can possibly arise? Well, let's look at what if we're just given a frequency distribution. So here's a question actually to start, something to think about. Suppose we are given a frequency distribution and don't have the actual data, because really they may not show you that, or you might even see the tally marks, but you just know that those you just know that you have numbers in those category, but you don't specifically know what those numbers are. How can we talk about maybe a measure of central tendency? So, but we want to estimate the average, let's say. So how do we do that? Excuse me. So basically, the answer is, well, if we don't know the specific values, we're just going to treat them all as kind of like the midpoint of the class. That's the best estimate that we can use. So that's the answer, at least the best answer, without any additional information. We approximate with class midpoints. So let's go ahead and do that. So let's say we have the class interval, the frequency, and we want to estimate the average. So on this chart we have 0 through 4, 5 through 9, 10 through 14, 15 through 19, and 20 through 24. And our frequencies are 3, 2, 7, 6, and 1. And then basically what we want to do is we want to add a class midpoint. So the midpoint is just the middle number. So the easiest way to do that is you just add the n numbers and then divide by 2. So this is our class midpoint. So we have 0 plus 4. 4 divided by 2 is 2. 5 plus 9 is 14. Divided by 2 is 7. 10 plus 14. 24 divided by 2 is 12. 15 plus 19. 34 over 2 is 17. 20 plus 24 is 44 divided by 2 is 22. So we have 22 as the class midpoint here. And basically what we do is, let's kind of write it down here, our strategy, and then we'll go ahead and implement that strategy. So to estimate the average, what we do is we multiply each midpoint by the adjacent frequency add those values. And divide by the total frequency. So our estimate for the average, how do we do that? Well, that squiggly just means it's approximate because we don't know the values. We multiply 3 by 2 for the first row. So we do 3 times 2, and then keep going. So go down to the next row. We have 2 times 7. And then we have 7 times 12. And then 6 times 17. And then 1 times 22. And we have to divide by the total frequency. So the total frequency, if you add this column up, you get the total frequency, which comes out to 3 plus 2 plus 7 plus 6 plus 1. That comes out to 19 total values. So we add all those up and then divide by 19. So this is exactly 228 over 19, which in fact comes out to exactly 22. So we see that our average using that method, oh, sorry, not 22, 12. Misspoke there. So the approximate average based on just this table is 12. So that will probably finish it for today, and in the next class we will talk about measures of central dispersion. So we'll look at the standard deviation, and then we'll also look at some examples with the normal curve. So there will not be any particular MyMathLab questions, but it's always a possibility that I might make an additional assignment for the normal curve. But just pay attention to your announcements and I will let you know about that. Okay, this is Dr. Lennon signing off.